Okay, today we're going to talk about ions. The subtitle is Noble Gas Envy. For those of you that aren't sure, envy means to be jealous. Okay? You like something that they have, or you want something that they have. Okay? So the question is, why would elements be envious or be jealous of noble gases? And the reason this is, noble gases do not react. The reason they don't react is they have a full valence shell. Because they have a full valence shell, we say that noble gases are stable. Noble gases are stable, other elements are not, but they want to be stable. So what we have to figure out now is what has to happen for those other elements to look like a noble gas, to be stable like a noble gas. So noble gases have full valence shells, other elements don't. So other elements have to gain more electrons. Or they could lose those electrons. Elements follow what's called the octet rule. It says atoms tend to gain or lose electrons to attain the electron arrangement of a noble gas. So basically, they want to look like a noble gas, so they'll get more electrons, or they'll lose electrons until they look like a noble gas. It's called the octet rule because most noble gases have 8 valence electrons. The only one that doesn't is helium, which only has 2 because the first shell needs 2 electrons to be considered full. Now to do some examples. In order to do this, what we do is the shell models, which we did a couple months ago. So just a quick memory, the period tells you the number of shells or energy levels. The group number tells you the valence electrons. So lithium is on period 2. So it has 2 shells. It's on group 1. So it has 1 valence electron. 2 electrons fit on the first shell. Lithium has a total of 3 protons. Protons, remember, have a positive charge. They also have 3 electrons, which have a negative charge. So right now, we have 3 positives and 3 negatives. Positive and negative cancel out. So right now, lithium is neutral. There is no charge. What we have to look at next is the noble gases that are close to lithium. If you were to look at your periodic tables, the 2 noble gases that lithium is closest to would be helium or neon. Okay. What we have to think of next is what does lithium have to do in order to look like helium? Helium only has 1 shell and it has 2 electrons on that shell. So lithium would need to lose 1 electron. Neon has 2 shells, 2 electrons on the first shell and 8 electrons on the second shell. So lithium would need to gain 7 electrons. Once you figure that out, you have to think, okay, electrons are lazy. What's going to be easier for the atom to do? Instead of trying to gain 7, it's a lot easier for lithium to just lose that 1 electron. And the way we represent that is we circle the electron, and we put an arrow going away because we're losing it. So we're getting rid of it. When this happens, the protons and the electrons are no longer even. So we're no longer neutral. We still have 3 protons because we did not touch the nucleus. But now we only have 2 electrons. Now we have a positive charge. And the way we write that is lithium plus. Okay. So now we'll do another one. Fluorine. Fluorine is also on the second period. So it has 2 shells. Fluorine is in group 7A. So it has 7 valence electrons. And of course, 2 electrons on the first shell. We have 9 protons. 9 electrons. So we're neutral. The noble gases near it are neon or helium. In order to look like neon, we just have to gain 1 electron. Because neon has 8, fluorine has 7. If we were to try to look like helium, we would have to lose all 7 valence electrons. So again, which one's easier? Gaining 1 would be easier for fluorine. The way we represent that is our electron with an arrow coming in, showing that we're gaining the electron. So now let's see what it did with the charges. We still have 9 protons, so 9 positives. But now we have 10 electrons. So 10 negatives. Now we have a negative charge. And the way we write that is F negative. When we have charged atoms, the positive or the negative, we call those ions. Okay, the electrons and the protons are no longer equal, so it has a charge. We call it an ion. The second word is pronounced cation. Okay, and a cation is a positively charged atom. And one way to remember that cations are positive is the T kind of looks like a plus sign. And the way an atom becomes positive is it loses electrons. The last word is anion, a negatively charged atom. Okay? One way to remember that an anion is negative is the A has like a minus sign in it. And to become an anion, you have to gain electrons. We'll do one more example. And by one more, I probably mean more than one. If we were to do beryllium, beryllium is also in period 2. So it has 2 shells. It's in group 2, so it has 2 valence electrons. 2 on the first shell. Right now, I haven't changed any electrons or protons, so it's all neutral. Again, it's close to helium or neon. To become helium, we have to lose 2. To become neon, we have to gain 6. It's easier to lose 2 than to try to gain 6. Didn't touch the nucleus, so we still have 4 protons. But now, I only have 2 electrons left. Cancel, cancel. We're left with 2 positives. So the way we write that out is beryllium plus 2. That plus 2 lets us know that we lost 2 electrons.